Hey guys, and welcome back to part 2 of the LibGDX Java tutorial series, where we are going to develop a small RPG game. So as mentioned in the last part, where we did the initial setup and some basic groundwork for the new project, we will in this part going to use the tiled map editor. As you can see it here, I will also add the link again in the video description below. You can download it if you use it for quite some time like I did and you have some spare money. Then I would say please also donate here. People with in the open source community, I think they always appreciate that. Also, from what I know, at the specific amount that you donate, I think the guy is working then on a feature request if you have a special one. And also I want to mention that there is also a Discord channel for Tiled. And there is always 1 or 2 people in it in the general chat, which are very helpful. So no matter what kind of question you have, there's always 1 or 2 guys which are there and can answer and help you with almost everything. At least that was my experience. So a very nice community there. And in general, a great program when it comes to tile maps, which we will create and explain a little bit in that part. So first of all, before we are going to open Tiled, so please download it. I have already downloaded it, installed it. I have everything available, so I won't do that, but you can do it on your own. But before we start into or dig into that, please note that on the Mystic tutorial repository with all my projects, I always mention in the credit section what kind of assets I'm using. And for that specific game, we are going to use the cute fantasy assets, which usually where I take my assets from is from itch.io. And then I start out with some free assets that I have there available. And then after some time, if the game has a certain maturity or if I share it with the public, then I also donate usually here. And this gives you sometimes some benefits where you get some extra asset stuff. And yeah, so itch.io in general for me, a very good website when it comes to assets. And again, we are using here the cute fantasy assets, which are also available on the project here. And before we start here creating our tiled map and using then the different graphic assets, I want to mention one specific issue that usually occurs when you use LibGDX and sprite graphics with a tiled map. There could be an issue which I cannot remember how it's called. It's not called ghost vertices. It's that is something from physics. But you might notice from time to time or from other tutorials that there are like lines between your tiled map. And these lines are usually some drawing artifacts which occur, I guess because of floating point inaccuracy with OpenGL maybe, but not 100% sure. And anyway, to avoid that problem that you have some artifact lines when drawing then your tiled map, which is a typical error that you face. You can find there a lot of topics in the internet when you search for that. And to fix that, it's very simple. You basically add some padding between your tiles. So when we take, let me show it to you, when we take as an example the cliff tiles, for example, this one here, there we usually split that up into several tiles. So for example, I don't know, this is maybe 64 by 64, I don't know. And we split it into 16 by 16 tiles, so in squares of the same size. And then the solution to fix this drawing artifact issue is simply that instead of having the tile set like that, we are simply extruding the edge pixels of each tile a certain amount of times. And this gives you like a margin or some spacing between the tiles with the where the color of the edge of a tile is simply duplicated a couple of times. And with that trick, let's say, we get rid of the artifacts drawing. For your personal experience, you can try and don't do whatever I do now or show you in a moment, and just use the tile set as it is. And then when it comes then to player movement, so when we move a little bit around with the camera then later on in the game, you will notice those little artifact lines then in the end. And yeah, the solution again is so-called tile extrusion. And we simply do that from the start, because later on, when you already have your tile set graphic available, you can imagine that as a single image with all the different tiles on it. And when you modify that later on, it is a little bit tricky or not so nice to fix that in the tiled map editor. So that's why usually at the beginning of a project, when you create your tile set, you need to invest a little bit of time or effort to have a good quality to start out in your game. So I would say for this part here, you can simply go again to the Mystic tutorial repository. There is a folder called Assets Raw, which is the original graphics that I use. And there, for example, in the map folder, you can download the different graphics that we are using. Ignore the back.json file. We come to that in a future part. So just the PNG files. And also maybe in the objects folder, you can download the house, the oak tree, the player, and whatever. So just some graphics that you want to use when we are now creating the tiled map. And when it comes now to this tile extrusion topic, I always used the command line tool in the past and always had to look up the commands and everything. And since that got a little bit annoying and I don't want it to look up all the time the different commands that I used in previous projects, I created a website. It's again on GitHub, open source, the Gdx-Quilly-Utils. I also add that as a link in the video description below. And there, maybe that one is nicer for you to view. There, one of the utilities is the tile extruder. And the way it works is that you simply upload one of your graphics. So let me go to the original graphic, for example, the cliff tiles, for example. So there we see the original tile set, which is 16 by 16 or 32 by 32. I cannot remember. I need to check that then. And there you simply specify the amount of pixels which should be extruded. So this defines like the gap between two tiles. And yeah, normally a value between 4 and 8 for me works quite well. So for example, if we use the value 8 and click on extrude, then it creates the extruded tile set for you that you see here below. It looks very similar to the original one, but you see here there's some little artifacts or pixel errors. It looks like a pixel error, but that is actually the extrusion effect. So in this website, you don't need to remember any command lines. You have that here available as a website. Again, upload it, specify here the different settings that you need, click on extrude, and then simply download the extruded tile set. And another thing that I often need with tile sets is that I need to combine certain images. Because as you see here, we have one graphic, for example, for the cliff tiles. Then we have another graphic for the beach tiles. Then for the bath tiles, water tiles, and so on. So we can upload all of them. Then you can specify here the order. For example, swap that around. Maybe we want to have the beach tile at the beginning. So this is how it works. You can simply drag and drop it around. Then you specify the size of the combined image in the end. So for example, we want to have a 2 by 2 graphic, which means 2 of these images are in the first row and 2 of these images are in the second row. And then when you click on combine image, then you simply get here all these images that you have specified here into one single image. It's very similar to a texture atlas that we will learn later on. It's not that optimized in the end. But for a tile set in the tiled map editor, for me, it's good enough. And yeah, the workflow that I usually use is that I simply combine all the images that I want to use in my tiled map and combine it here with this image combiner tool. And then this combined image in the end, that one I run through the tile extruder once more, so that I avoid the artifact rendering then later on in LibGDX. So 2 steps: first image combination, and then the tileset extrusion, and that's it. And in the end, what we then get, so I don't do that here because I did that already in the original repository. So there under assets and maps, there you can find the tileset.png. And that is basically the combination of the different images that we have seen before with an extrusion factor of 8, if I remember correctly. And in the end, we simply want to, or I, as a demonstration here, I will simply use that one here for the map drawing. And in addition, in the objects folder, because I also show that then in this part, I will download the house, the oak tree, and the player so that we have a couple of graphics to work with. Okay, so I'm finished in what I did in the assets folder of the project. There, first of all, we can remove the git keep and the assets text file. They are not needed. And there I created a folder which I called maps. In the maps, I have the tileset graphic from the repository. And there I have another folder called objects. And in that objects folder, I have the house, the tree, and the player. And that's it. So that's everything that we need in that part. As a next step, we are going to open Tiled. And in Tiled, when you open it up, it should look like this on your end. And there we are going to create a so-called new project, which we will also place under our music tutorial YouTube assets maps folder. And let's call that, I don't know, Tiled project, I don't know, give it a better name. So this is some project name. And yeah, once we have created the project, we want to create a new map. And there, let me quickly look up what are the real dimensions of everything. Okay, we have a 16 by 16 tile set in the end. So each tile is 16 by 16 pixels. And as a width, I don't know, we use 30 here, a height of 20, doesn't really matter. One important part, there would also be the possibility of infinite maps. From what I understand, it simply stores then a specific area of the map in chunks, and you can simply have then an infinite amount of chunks and create an infinite world. But that is currently not supported by LibGDX, so we don't have that available. We need to use fixed map sizes for now because infinite maps won't work. And yet for orientation, I think it doesn't really matter when it comes then to LibGDX. It's simply what kind of... this one does matter actually. So it defines if it's an orthogonal isometric map or an hexagonal tile map. So there are different kind of tiled maps. We are simply using an orthogonal, which is the normal 2D map. Then the format in which we want to save it. I normally use base64 clib compressed, if I remember correctly. If it's CSV, then you can read the values in the XML file more easily. With base64, it's then simply encoded a little bit. And with the compression, you simply get smaller file sizes in the end. But yeah, let's use a clib compression. And the render order, that is the one that I meant. That doesn't really matter in LibGDX because OpenGL always renders from, I think, top left to bottom right, if I remember correctly. And here you can simply specify the order. I think in DirectX from the bottom left to the top right. And we just use left down, right down. I think right down. I don't know. Doesn't really matter. Okay, so here we have now our map. And what is important, we also have our project created. So first of all, let's save this map. So I simply press Ctrl and S. Because there are two versions how you can save a map. Actually, there are 3, but only 2 of them are supported in LibGDX. You can save your map as an XML file, which is the TMX format, or you can save it as a JSON file, which is the TMJ format. TMJ was just added recently to LibGDX, and TMX is the old file format, I would say, which existed for a long time. And yeah, for simplicity, we will stick to the XML format and call our first map, for example, the main map. Okay, then before we go into the little buttons here at the top and what you can do here, we first need to create a tile set so that we can start drawing here our map. For that, you can click on the new tile set button, give it a name, I don't know, also tile set, for example. Then the type, we can base our tile set on an image, or we can make a collection of images. And actually, we will use both of them, but for now, we use based on a tile set image. You can embed the tile set in a map, but I prefer to have it as a separate file and don't embed it inside the TMX file. So we have that separate. And the source is simply the tile set graphic here, which also has a 16 by 16 dimension. And now for margin and spacing, we need to consider the extrusion value that we used. So since the tile set has an extrusion value of 8, our margin, so the space between the tile and the edge of the graphic is 8 pixels. And the spacing, so that the space between two tiles is simply twice the margin. So if you have an extrusion factor of 8, then between two tiles, there will be a space of 16. 8 pixels from the right tile and 8 pixels from the left tile, or 8 pixels from the top tile and 8 pixels from the bottom tile. So there's this space of 16 pixels. And if we did everything correctly, so we saved that here also as the tile set. For the tile set, again, you can choose between the XML and JSON format. I would not recommend to combine it or use different formats. So for example, XML format for the map and JSON for the tile set, or vice versa. Don't do that. Stick to one format and that's it. So for me, since we used XML before, we will also use XML for the tile set. Okay, and let me zoom in a little bit, and that looks good. So you relatively quickly notice if you have messed something up with the margin spacing values or with the tile dimensions when you don't see here the correct graphic. So if there is some offset, or if they just don't look like the original graphic, then you messed something up there. And for us, yeah, it looks good here, so everything is fine. Also from what I know, so under tileset and tileset properties, you can see here the settings for margin and spacing. And I don't know why, but you cannot modify that here later on in the editor itself. But you can simply open the XML file and then change those values. And that always worked for me. So if I wanted to try something or mess something up there, you can still fix it later on if you directly modify the XML file. I don't know why you cannot do it here directly in the editor. Not sure why, but just that you know that you can simply fix the file itself. Okay, good. So we have a tileset available. We have our map available. And now I just want to explain some basic functionality of the tiled map editor. I won't go into detail of everything because that simply takes too much time for that part. And you can simply look that up in the online documentation and try it out yourself. I think it's best if you just play a little bit around with that editor and learn the things by hand. Okay, so what we need to draw something on the map, we need so-called layers. So when we go here, we always have one initial layer, which is called the tile layer. You can rename that to, for example, that would be our ground layer. Then we create another tile layer, which we maybe call background. Then another layer, which we can, for example, call foreground. And basically, it's like in a normal image program. you can have different layers of your tiles in the end. And the lowest one, so in this case, the ground one will be rendered first, and the foreground will be rendered last, which means it's simply on top of that. So what does that mean? So for example, for the ground, let's take the one of the grass tiles, that one here below. Let's select the bucket and fill everything now with our grass. And now if we, for example, would use the footsteps here and go back to the stamp, I think it's this one. No, this is the stamp brush, it's B. Then we can also simply update certain tiles and put some footsteps here on our ground. Then in the background, for example, we can use a cliff here. For example, do something like that. Okay, that doesn't really look good. It should be like this. Then the cliff goes a little bit down, something like that. I don't draw here everything perfectly. You can create a beautiful map there. I will simply then load the map from the online repository and use that one here. And here you can see, so for example, when I hide the ground layer, then you still see here the background layer rendered. So that there's really different layers and they are rendered one by one. And yeah, I think that is one of the main features, I would say, of Tiled, that you have here different tile layers, and then you simply draw your map with the different tiles. There are a couple of nice features, and I show a few of them. So one of them, for example, is that you can flip your tile. So for example, imagine you have here a specific tile and you need the flipped version of it, either horizontally or vertically, so it's X and Y. Then with the X hotkey, you can flip it, or with the Y hotkey, you can also flip it. So you don't need to draw every possible combination of a tile in every specific angle. You can also use some flipping. You can also rotate it by 90 degrees. Those are the buttons here on the top right side with the button thing. So, and all of that is supported in LibGDX. So whatever transformation you do here with your tiles, they will then correctly show up in LibGDX when we load this tile map and render it, which is happening then in the next part. Then there are also other layers. So for now, we just created tile layers, which are the ones that we wanted to use to render our tile map. But there are also image layers, which is simply a static image in your map. Object layers, which is for the game objects. In our case, that would be, for example, the player then that we are loading in our game. And there are also group layers that you can group, as the name suggests, or implies that you can group certain layers together. That might be useful, for example, for a jump and run game. And if you use some parallax effect with your background, then you might want to group certain background layers together, that the parallax scrolling effect is the same. What is a parallax scroll factor? So here, when I select, for example, the ground layer, and I choose here on the x-axis, for example, a parallax factor of 2, then, can I zoom out here a little bit? I'm not sure. Basically, when you now move the camera left or right, it's a little bit hard to grasp here the idea, but basically the layer doesn't move with the exact speed of the camera, so it doesn't stick to the camera that we do or that we have, like here with the cliff. That one always sticks at the same location. You see here the map borders, the black lines, and the cliff itself always remains at the same location. But when we use a parallax factor, then it simply scrolls with a different speed, and the position of the layer then simply moves a little bit. So in that case, since we modified the X parallax factor, then the layer on the X-axis will scroll a little bit slower or faster, depending on what factor you use. And that one can be used, for example, in a jump and run. You can imagine it like that in Super Mario Brothers, where you maybe have a a blue background for the sky with some clouds. And if the clouds should then move with a certain speed so that you have some depth effect in your game, then you can use, for example, this parallax scrolling factor, which is also supported by LibGDX. So that everything here is working fine and can be used. But yeah, since we have an RPG here, we don't need that. Yeah, so I would say let's create an object layer. Let's call that objects for now, so that we also see that here as well. And objects are usually rendered between the background and the foreground. So we place that here. And now we want to create another tile set, which is now the collection of images. And we can call that an objects tile set. Also the XML format again. And now we have an empty tile set. And with this plus icon here, we can now add images to this tile set. So a house, oak tree, and a player. There is a button, this one here, dynamically wrapped tiles. So since those graphics have a different size, but they are still displayed in a grid, it sometimes looks a little bit weird if they don't have the correct dimensions, at least for me. So that's why I always activate this button here, the dynamical wrapping, which simply then makes them the same size, so that when we have this grid representation of the different images, then every image here has the same size and it simply looks better. And yeah, what we can do here, I don't focus on that in that part, but basically what we can do here, we have now, for example, our player object, which is this one here, and we can add some properties to our player. For example, a move speed, which would be a floating point number. And the player, for example, has a speed of 3. Or we can give him some hit points, for example, life. And the player has, for example, 10 life. So things like that. And there I nowadays use this collection of images tile set because it's a very, in my opinion, nice functionality to configure my game objects. Because one of the images is always linked to a graphic, which I already have available. I can modify the sizes, I can give it some properties, and what is also nice, we can then later on also create here collision within tiled, and yeah, use a lot of features in the tiled map editor to create our game objects. And in the end, so when we go back to our map here in the objects layer, we can then with that button here insert tile from the objects layer. We can click on our player here and, for example, move or create a player object here, or create a tree here, another tree here, and the house, for example, here. Something like that. In addition, whoops, that was too much. In addition, when you select an object, you can also give it a name. For example, here, player. Then you also have here some text so that you can easily see where things are located and what they are. And if you're lost because you have too many objects or the map is maybe too big, then there is also this objects tab here where you have a list of all the different objects and to which layer they belong. And you can click there so that the editor then focuses on those tiles or those objects. Okay, but for object itself, I will focus on that then in a future part when we really integrate that in LibGDX. Yeah, one of the last things, okay, there are a couple of more things, but one more thing that I want to show you is also the animated tiles. So when we go back to our tile set, then here for the water, we have 4 different tiles, which together would be an animation for this water ripple effect. And we simply click on one of these tiles, and then you can open the tile animation editor. And there we can add the different animations for that specific tile. So we click the first one, then the second one, third one, and fourth one. Can I somehow zoom in here a little bit? Okay, so here we see it a little bit. Here is the time between or how long the animation remains in that specific frame. So for example, currently it's 200 milliseconds, 100 milliseconds for every frame. We can change that to 200, click on apply. Then the ripple effect, as you see it here, is simply a little bit slower. If we want to have it faster, it could be, for example, 50. Then it's faster. I think 200 looked quite good. And it's quite dynamic. So you can have a different time for every frame, whatever you prefer here. And once you are done, you see here a special overlay icon on the tile if it has a specific animation. Then you have this videotape or whatever that should be, so that you know that is an animated tile. And now, when we go back to our main map, for example, to the ground, and we select now the water ripple effect and place it on the map, then you see here that this animation is also playing. And again, this is an out-of-the-box feature again in LibGDX. So when we load the tiled map, then we also have these animated tiles available, which is also great. Okay, then two more features that I want to show related to tile sets and also to tile sets, also to the object tile set. Next to the tile animation editor, there is also a collision editor, which is automatically opened on the right side. So for example, let's take this cliff here. Let me zoom in here again a little bit to 100% that you see it a little bit, maybe even more, 800. So there we have the tile collision editor. And what we can do, there is a button which is called detect bounding box, which from what I know, it simply detects what pixels are transparent and which ones are not, and then simply makes a box around that. And in our case, we don't want to have a collision for everything. We really just want to have it for the cliff itself. So we make it here a little bit smaller, also here a little bit smaller, and that's it. So below here again, you have a list of the different collision shapes a tile can have. A tile can have multiple shapes. Also, it does not have to be just a box. So for example, here, let's go to this corner case. We can also use, for example, a polygon and draw something like that. Just some arbitrary stuff here. So a polygon like that, which would be now a collision shape. We also have ellipses. We have a point. A point doesn't really make sense for a collision, but an ellipsis is also a circle if you modify it, and the rectangle, and of course also just a line, which would also be possible. And that's it about the collision editor. When we go back to our map itself, we can, I have that already available, but under view, you can click on, where is it? Show tile collision shape. So here, currently we don't see it, but when you enable show tile collision shapes, then you also automatically see what kind of collision areas you would have in your map and how it looks like. So here we simply do it per tile, and later on then in LibGDX we create some logic for it with the Box2D physics engine that we then create static bodies for that, so that we really have then the collision that we see here in tiled, that we also have that available in LibGDX. Okay, so that's the collision editor. And one final gimmick or nice feature when it comes to the tile set itself is the terrain brush, which we can select here, a terrain set, sorry, it's called like that. And in our case, it would be, for example, a corner set, if I am not mistaken. Let's see. So we will have a terrain brush or terrain set is always a combination of at least two types of terrain. So for example, in our case, it could be grass and sand, or sand and water, or whatever combinations we have. I will use here maybe grass and the cliff. Let me try that one here. So the first one will be grass, And the second one will be the cliff. And now when you go to patterns, that is at least how I use it, and the only way I ever understand this terrain brush stuffy. So when you go to terrain, we have now a corner set. We have created two types of terrain. And when we click on patterns, we now need to select at least one tile for each of the pattern. So red is the grass and green is the cliff. So here, this one here, that pattern here, that would be, for example, the grass here below. Then we need another one where the grass is like that. The green part is the cliff here. And we simply fill out here all the different patterns that we can find. So give me a moment to select all of that. I think some of them are missing. So we won't have everything available, but even if there are some of them missing, it will still work, not perfectly, but still works in some way. We will see that in a moment. Okay, let's try it like that. So a couple of patterns, as you can see it here, they are still in a bright color, 1, 2, 3 in total. I couldn't find them. The other patterns, I think they should be okay. And the way it now works when we go back to our main map and we go, for example, to the ground, and there we have, that is important, we have filled already the ground layer with our grass tile, which is when we come back to the terrain set, which is this pattern here. So the red square here below, which is our grass. That one needs to be available so that tile then knows with the terrain brush how it should match the surrounding tiles to the initial one. So since we have filled everything with the ground tile, it should theoretically work. So let me switch to the terrain set. And I now click to live. Okay. And now when I draw here a little bit, okay, it looks a little bit like garbage if I'm honest. Okay, now if I draw here, so for example, a line, you can see that it correctly creates here this cliff. Obviously, I didn't match the patterns correctly or perfectly, because when I go here, you see it would draw something really weird. So that is broken. I did something wrong, but I think you get the idea. So basically, for every pattern that you have here, you need to select here the correct tile. And then you can use this terrain brush for drawing some things. That would be it. Okay, and the last feature that I'm going to show, and that's it then, is since we have created a project in Tiled, you can use so-called custom types. And a type could be either an enumeration. So for example, an enumeration could be, I don't know, our object type maybe in the game. And by default, it's maybe undefined. Then we also have the player object type. We have maybe a prop object type, something like that. So an enumeration, like in Java, we can create that and use that then as a property, like we have seen it before. And another thing would be a class, which could be, for example, I don't know, a prop object. And a prop object maybe has a dimension, doesn't really matter, which is a string. And another member would be, maybe it has a color, for example, which we call a color. And you can then specify where you want to assign that class. So can it be assigned as a property to a map, to a layer, to an object, to a tileset, and so on. If, for example, it should not be a map class property, then untick it. No, we just want to have it, for example, for a tile in that specific case. So we have it like that. And this information here, enumerations and classes, they are stored in the project file that we have saved initially. And yeah, as mentioned, when we now go, for example, to our player here, then we can either add a custom property, where we we can now choose our class, for example, or the enumeration. That one was the class, the property as a class. That could be our prop class. Then you get here automatically all these properties available. It's like a template, I would say. We will use that later on as a template for our game object so that we don't have to add every property one by one, so that we just need to select the class and then we have the all the different properties available for a game object. So that is where I am using the classes and the enumerations. Another option would be that you simply select the class here at the top. When you do that, then also here below, you automatically get the properties available. So those are the two approaches how you can use classes in Tiled. Okay, and that's it for that part. So this part simply covered a couple of features when it comes to the Tiled map editor, the different tile sets that we have available, the different formats with XML JSON, how to use it to create the initial tiled map. And now I would say simply create your own tiled map, create your own idea, create your own objects and so on. And in one of the next parts, we are then really loading that specific tiled map in LibGDX and show it then in our game window. That's it. Thanks for watching. Have a nice rest of the day and bye-bye.